Find the length of the curve. X equals cosine of t, y equals sine of t, where t runs between 0 and 2 pi. So here we have a set of parametric equations which defines a plane curve, and we want to find the length of that curve. Remember that for parametric equations, the arc length formula is the integral from a to b, the square root, dx dt, or dx d, the parameter, whatever that may be, in this case it's t, squared, plus dy dt squared dt. So we need to find the derivative of x with respect to t, the derivative of y with respect to t, put those in, and of course use our limits of integration, a to b, which in this case is from 0 to 2 pi. So for us, in this problem, we have the integral from 0 to 2 pi, the square root, the derivative of x with respect to t, well, the derivative of cosine with respect to t, so if we write over here, the derivative of x with respect to t, that's equal to negative sine of t. So negative sine of t squared. Now, dy dt, that's the derivative of y with respect to t. Y is equal to the sine of t, so dy dt is going to be cosine of t. So plus cosine of t squared. And then dt outside the square root. Okay, now we try to evaluate this integral to find our arc length. We can quickly simplify the inside. Whenever you square a negative, it goes away. So we have the sine of t squared plus the cosine of t squared dt. And we know that from the fundamental trigonometric identity, the sine of t squared plus the cosine of t squared is equal to 1. So we really have the integral from 0 to 2 pi of 1 dt. When you integrate that, the antiderivative of 1 is t, and we're going to evaluate that from 0 to 2 pi. So remember that we plug in the top number first, the upper limit of integration, which in this case is 2 pi. Then you subtract and you put in the lower limit of integration, which is 0. So our arc length in this case is 2 pi. That should make great sense, because if you look at this parameterization, x equals cosine of t, y equals sine of t, the rectangular equation for this parameterization is x squared plus y squared equals 1, which is the unit circle. It's a circle with radius 1, and the arc length of a circle is the same as the circumference of the circle. And so in this case, indeed, the arc length should be 2 pi. Now, we may not have known that the rectangular equation before, but it didn't matter. We can evaluate that arc length using the parametric form of the arc length formula.